Solve the triangle. A is equal to 57.5 centimeters, C is equal to 49.8 centimeters, and alpha is 136 degrees. So I have another side-side angle. This is our ambiguous case. So I'm going to start by drawing the angle here. I always do that with side-side angle. So that's angle alpha, 136 degrees. Side A would have to be across from that. And I always imagine that I've drawn the other side. So I drew this side, so that C is equal to 49.8 centimeters. But as long as the right side is across from the correct angle, everything is really fine, and it doesn't really matter how we label these. So this is B, angle beta, and side B. All right, so I need to find a missing angle. That first missing angle I can find is gamma because I know the side across from it. So sine of gamma divided by 49.8 centimeters is equal to the sine of my 136 degree angle over 57.5 centimeters. All right, so let us find gamma. 49.8, imagining multiplying that to the other side, times the sine of 136, divided by 57.5. And so sine of gamma is about 0.601. Using inverse sine, I find out that the angle here is about 36.99 degrees, which I'm just going to round to one decimal place here, 37.0 degrees, which is the same as rounding to no decimal places, and that matches what's in the triangle. Of course, if I was given rounding information, I'd follow that. But I remember here, because I'm using the law of sines, I take an inverse sine, which can only find acute angles. There might be an obtuse angle that would work. So for a moment, I think this angle might also get to be 143 degrees. But that should have been clearly not a real possibility from the beginning. See, I know this triangle has a 136 degree angle in it. Well, triangles can at most have one obtuse angle. There's nowhere near enough room to have another obtuse angle in there. So this triangle's definitely going to have one solution. And this one's kind of nice that I could tell that right away from that being an obtuse angle, and I didn't even really have to check. That being said, I'm always just going to go on and do that out of habit. And that way, I always find a second solution if there is one. But this triangle is only going to have one solution. All right, well, if I know three angles, I can find, if I know two angles, I can find the missing third angle. And here, that would be beta. 136 plus 37. And now I need to imagine taking that away from 180. That's going to be pretty easy to do. I'm going to find out that's a 7 degree angle up there at the top. So not to scale, right? That should be a much smaller angle there if I was to draw this to scale, but that's okay. All right, so I have everything I need except for side length B. B over the sine of 7 degrees is equal to 57.5 centimeters over the sine of 136 degrees. I can find B. Multiply both sides by the sine of 7 degrees. And I find out that B is about 10.1 centimeters. And we have solved our triangle. This one only has one solution, and that's it for now.